Class AP style problem gives us a system with a gas and a table of values. All right, so instead of reproducing that whole table, I want to point out, as you can look at yours, that you got to notice two things. At time zero, all the pressure happens to be the carbon dioxide, right? Because that's what we started with. Then, by the time 8 hours has passed, we've got equilibrium, so now we have a mix of both of these gases. The pressure goes up because every time 1 mole of carbon dioxide disappears, 2 moles of carbon monoxide appear, so we end up gaining 1 mole for every time the reaction shifts to the right. Then we get to equilibrium and it stabilizes. So our first question is to write the expression for the equilibrium constant, Kp. They tell us do Kp, and that becomes super easy. So look, Kp is the partial pressure of carbon monoxide squared, because we have a 2 here, and over the partial pressure of CO2. Now, I did not include anything for carbon because it's a solid, and solids don't have any pressure. All right, or you could think of it as their pressure is constant. And if it's constant, that means it's included in the equilibrium constant. But only the gases are showing up over here because they're the only things that have pressures. So then we have to get the number of moles of CO2 initially in the container. All right, and that is easy. We're just going to use the ideal gas law, rearrange it to find the number of moles because we know what pressure of carbon dioxide we have at the beginning. We know the volume and we know the temperature. So initially, all the pressure comes from carbon dioxide. That's why I use the 5 atmospheres, and everything else is straight from the problem. And we end up with 0.015 moles of carbon dioxide. Then we need to think about it at equilibrium. We've got the partial pressure of CO2 now. So we need to find the partial pressure of carbon monoxide and the value of the equilibrium constant. So first, to get that pressure of carbon monoxide, the total pressure, which is 8.37 from the table, has to be the sum of the two partial pressures. So that means if I'm given this one, partial pressure of CO2, which I am, I can just substitute it and do a little algebra to solve for the partial pressure of carbon monoxide, and I find out that it is 6.74 atmospheres. So now I know both partial pressures, 6.74 and 1.63, and I can substitute them into the expression. Remembering, I've got 2 carbon monoxides for every carbon dioxide, so that's why I get a 2 up there. And I come up with a Kp of 27.9. Now, these next ones are more information that you pick up from the chapter and other just reading about how catalysts, okay, what's the effect of a catalyst on equilibrium? And the answer is in the format, same as number 4, that they ask us to first make this information available, greater than, less than, or equal to the final total pressure, all right? And then justify. So you have to answer in that pattern. The final total pressure would be the same. That was one of my choices. Equal to the final total pressure, all right? And because catalysts speed up reactions, so they reach equilibrium faster, but it's the same equilibrium. Another way of saying this is realizing that the catalyst increases both the forward and the reverse rate. And then in another experiment, but it's the exact same system, now it's a 2-liter container, and it has 10 grams of carbon plus both of the gases, but each of them has a partial pressure of 2 atmospheres. So whether this, the partial pressure of CO2, will increase, decrease, or remain the same. And then justify. So we have that answering pattern again. You have to pick one of those and then justify. So when we think about it, we can come up with this, that the partial pressure will decrease. So carbon dioxide will be less at equilibrium than it is at the beginning of this. Now why? The initial value from Kp, if I plug in those partial pressures, 2 atmospheres for each of them, that in this case, when I begin, my Kp calculates out to be 2. Now that's less than the equilibrium value. Kp is 27.9. So in order to get from 2 up to 27.9, I have to produce more products. So CO, and consume CO2 to get there, which means that the amount of CO2 will be lowering as it reaches equilibrium. That's why the pressure will decrease.